Okay, so next is run length encoding. So in lossless coding, we only learn only two type of algorithm. Okay, the first one is Huffman, and the second one is run length encoding. So RLC is an image compression method that works by counting the number of adjacent. Okay, you have to count the number of adjacent pixels with the same gray level. Okay, so this count called the run length and is then coded and stored. So there are many versions of RLC. Okay, so it can be in a binary image, which is a basic method. Okay, just count the pixel with the value of 0, and also by count the pixel with the gray level 1. Okay, so there will be another extended version, okay, which is grayscale images, which is more complex, where you will have a more number of gray level, okay, to be counted. So there are two types of RLC. So it can be done either horizontally or vertically. So horizontal means you have to count row by row. Okay, row by row. If vertical, you should count along column. Okay, so the number of bits used for coding depends on the number of pixels in a row. So if the row has 2n pixels, then the required number of bits is n. So for example, you have 256 times 256 image require 8 bits. So since 2 power of 8 is 256, then the number of bits is n. Okay. So the next step is to define the convention for the first RLC number in a row. So you have to, so in run length, there will be two main things that you have to identify first, okay, before you apply the RLC. So it either by row or by column. By row means you have to count row by row. Okay, if by column, so you have to count column by column. So another thing is what representation, the run that you want to count. So it either 0 or 1. If 0, then you have to count. Okay, how many zeros? If 1, how many 1? Okay, but the difference with these two is by the first pixel value that you count. Either it is 0 or 1. If 0, then you just directly start counting. Okay, there will be 8 zeros. Okay, second row, since it starts with 1, then you have to count the number of 0 first. Means there is no 0, so it will be 0. And then start count the next one. Okay, the pixel of 1. Okay, there will be 4 and 4. Next, first start with 0, so you directly calculate as 1, 2, 5. 1, 5, 2. 1, 3, 2, 1, 1. 2, 1, 2, 2, 1. Okay, again, this one start with 1. Okay, so there will be no 0, so you have to count the 0 first. So means that you have to count as 0. So since there is no 0, so you have to count 0 as 0, and then continue with 4, 1, 1, 2. Okay, so the last one, 8. So you can see the example here. Okay, so apply RLC using horizontal, and the first run is 0. So these are the two things that you have to identify first before you do the RLC. So either it is horizontal or vertical, and what is the first run that you want to count. So if the first run you want to count is 0, then look for the 0 first. Okay, so as been mentioned before, first row 8. Okay, next row, first row, second row 0, 4, 4. How do you get 0, 4, 4? Is by counting the first as 0 first. Since they start with 1, so means there is no 0. So you have to count 0 as 0. 0, 4, 4. Okay, and then 1, 2, 5. 1, 2, 5. Okay, and keep on continue until this row. So for this row means 0, 4, 1, 1, 2. 0, 4, 1, 1, 2. Okay. So if it is in horizontal, then you have to calculate horizontal. Horizontal means you have to count column by column. So you want to count horizontal, and the first run is 0. So it means that 1, 1, 4, 1, 1. 1, 4, 1, 1, 1. Okay, and until the end. If you want to count horizontally and the first run is 1, then this one will be, there is no 1. So what you have to do is to count the 1 first. So means that there will be no 1. So 0. Okay, and then 8. Okay, so this is horizontal and count 1. So there is no 1. So 1 is 0. Okay, and 8, 0. The first one, the second row, start with 1. Then you directly calculate as 4 and 4. So the third row start with 0. So you count 1. There is no 1. So you count 1 is 0. And then start counting 0. Okay. And then 0, 1, 0, 2, and 5. Okay. So then you keep on count. So the main thing to start the RLC, you have to identify either it is horizontally or and also what is the first count that you want to, first run that you want to count, either 0 or 1. Okay, so next is second category of compression is lossy. So in order to achieve high compression ratio with complex images, lossy compression method are required. Okay, so remember, lossy, you will get high compression ratio, but you tend to lose the information. So lossy compression provide trade-offs between image quality and degree of compression. Okay, so you don't have to get high compression ratio, okay, but you lost the information, the quality will be reduced. So you have to trade off between these two, quality and degree of compression. So this allows the compression algorithm to be customized to the application. So with some of the more advanced method, images can be compressed 10 to 20 times in virtually no visible information loss. Okay, you can compress up to 10 or to 20 times, okay, of the original, okay, with virtually no visible information will loss. So compression up to 30 to 50 times is also possible with minimal degradation. So if you go higher, so possible to have minimal degradation. So image enhancement and restoration technique can also be used to improve the appearance of decompressed image. Okay, one way to solve the lossy compression is by do the post processing, which you followed the compression technique by the image enhancement or restoration technique. Okay, so that's finish of the compression topic. So there will be exercise here. So please do the exercise. Okay, thank you.